Welcome back, everybody. 2009 Honda ST1300. We're going to be doing some electrical work today. I don't have any turn signals. I would like them. This is a test bike for the police in my area. When I picked it up, there's no fairings. The only thing I have are the switches on the handlebars. I also know there's some shady electrical work that I need to address at the same time as we're doing this. The things that you will absolutely need are a multimeter and Honda Haynes or wiring diagrams for the bike. Absolute necessity for both. If you have any issues or fears about doing electrical work, we're going to hopefully get rid of those fears for you. This will be a beginner to intermediate kind of video to help you understand what tests can be done to figure out situations that you don't quite understand. You just need the right materials and patience. As you can see, I have my wiring harness down to the bare bones, the skeleton, to find out what is going on with my turn signals. I do have tail lights that are functioning. We have located our relay for our turn signal switch, which is a 3-prong relay that I have gotten a replacement for. Now, wire color is important. A red with green tracer. This is a gray wire in the middle. It is oxidized over time and turned yellow. And then green. Green is ground. That is important to remember. As we look at our Haynes manual, a lot of this is a mess. Some of it can be difficult to interpret. But as long as we know that green is ground, the only colors that I'm worried about are the front left and front right turn signals, orange and blue, as well as the rear, orange and blue. With that information, we can begin testing specific parts of the bike to find out what's wrong. Now, I've spent all afternoon actually figuring out what is wrong with my bike. It took me about 2.5 hours. There are specific tests that I wanted to do to find out, one, if there were any breaks in any of my harness lines, and two, to make sure that the relay was working as well as the switch. I purchased a new switch, new to me, still a 2009 handlebar switch for the turn signals, and a new relay. I was able to test the relay, and I could hear it click and function, but I wasn't sure entirely that it was 100%. Bought a new one, it was $33 online, and the switch, I think, was $40 off of eBay. If you don't have those issues, you know they're good. We're looking at wiring harness itself. We're gonna do some tests right now to identify your issue. All right, you've done the easy stuff. You've turned the bike on. You've touched switches, you've hit brakes. You know that there's an issue with a particular part of the system. I know my running lights work, my headlight works, my brake lights work for front and rear brakes. I know it's a turn signal system specifically. Check fuses as well, because all too often something simple is usually the cause. Now, I know with this bike, it was going to be a wire harness issue because of what this bike has been through. The first test that I'm going to want to do is an open line test, a resistance test. I've got my multimeter set on beep instead of resistance or ohms, so that way I know if the line is open, I'm not going to hear anything. If the line is good, I'm going to hear a beep, and I know that line is okay. I'm going to keep going. After I open up my harness, I found probably about a dozen wires cut that were unnecessary at the time for the bike. The first test we're going to do is a resistance test for the right-hand turn signals, which I know is blue. So I have one of my multimeter probes connected to the red connector on the handlebar switch for the left-hand side. I'm going to connect it to the cut blue wire that I have confirmed is for the right-hand turn signal. If I connect this, I should hear a beep. I know that from this broken line to my connector, I'm good. Let's move on to the next test. Because this harness runs front to back, there are 2 lines, one for the front, one for the rear. Only my front is cut. My rear actually is still connected. So, because I did my test, that shows ground is good and passage for electricity is good for the entire system. If it weren't, I'd still have an open line and no beep. This is the break in my line for my right hand turn signal. After
we finish the other diagnostics, we'll do install for that, we'll test the light to ensure that it works, that the system is complete. Second test, the left-hand turn signal. I have 2 cut orange wires with silver dot tracers on them. I'm twisting them together. My second test, since I've moved my probe on my switch to the orange line, I should be able to hook this up and hear that beep. Lets me know that system has now been addressed and has an entirely connected source from start to finish. That's what's important to find out. Those 2 together are my break. You've diagnosed your circuits for the right and left turn signals. We're going to diagnose the relay now. We mentioned there's 3-prong for this: a ground, a power, and a signal. Red with green tracer is power, because we mentioned green is ground, gray is signal for that relay. I've tested that with our multimeter, the same way we tested the other circuits. We'll move on to the next tests to do continuity for power and ground for the relay. Now, in my harness, I have 3 red with green tracer wires connected randomly. This is one of my issues with this bike, is that I have shady wiring connected. I believe they are part of the relay system. So I'm going to do a continuity test between these 3 connected and pin the back of the relay. I have my sound. That means this system is where it needs to be. I'm going to go further up from this break forward, because I know that from here on back, everything is okay. From here forward is where I need to find out where my issue is. So I can do another continuity test to find out that this random wire for a connector that doesn't even connect to anything actually does belong to my relay system. That is my power line. I have found the break in my power line. Now I need to find a power source to connect this to provide power to my turn signal relay. Let's move to the ground. As we mentioned before, green is ground for Honda, the entirety of the bike. So the green wire coming out is actually ground for the turn signal. So all I need to do is find the exact wire that belongs to that, which is in the same switch as the power for the turn signal relay. My continuity test will show me whether or not I've got the right wire. It's correct. Now I just need to find a good ground for this particular wire. I can use a body ground really anywhere. It's not specific. At one point in time, it did have a specific ground through a switch connected to fairings. I don't have that anymore. We need to improvise. So you've done the continuity tests. We know where our brakes are, where they need to be connected, and how to get there. Now we're going to switch our position on our multimeter. I'm going to switch to 12 volts. It's a 12 volt bike. We're going to test power and ground to find out where a power source for my relay is. Now I could choose constant power, but that means that even with the bike off, the relay is going to be powered, which drains energy from the bike and the battery. So let's find a switch on power line to do this for. It's as easy as testing a red wire, thicker in gauge. You may find a tracer. I found a convenient red with black tracer on my main harness switch that is in this 3 connector for the handlebar switch to the front of the bike for the ignition that I can use for my turn signal relay. Now I'm going to choose a random ground on the bike. Anywhere really works as long as it's an actual ground, there's not plastic around it. I can actually use my fender flares to do so. And then I'm going to plug into the back of this switch, and then it's going to let me know I don't have any voltage right now, but when I hit my switch, I have full 12.5 volts for the bike. Turn it back off, it goes right back to 0. At the same time I'm finding grounds for my turn signals and my relay, I'm also finding grounds for my turn signal bulbs. So I have connected my headlight ground. Both of my turn signal grounds, they're going to go to this body ground that shares with the ignition switch as well. I don't want to shove all of them in there, so I'm butt connecting 3 that I know will be used at the same time. separate from the starter ignition switch. I've made some connections on my bike. This is my power, red with green, spliced with the ignition switch on power. I have my left hand turn signal wire as well for signal. I have spliced these two, since they were cut, into one. I'll have to splice here again. This is to test that I've got the right side. I've got my grounds. So what I would do right now is hit my turn signal switch. I have a turn signal. And then to test for my hazards work as well, which means I can see on the back wall that those lights are working also, which means I have power, ground, signal, and the left hand turn signal correct wire. I do the same thing for the right side. We'll do a portion on this as well. After my jumbled mess, I have connected my right side turn signal. So now when I activate my hazards, both front and rear, lights activate, as well as left and right. Not only have I fixed my turn signal issue, I have installed turn signals. The system now works. We installed turn signals and diagnosed an electrical issue with the bike. Hopefully this helped you out in some way with electrical diagnostic, or at least tackling some kind of electrical install for your